Imagine you are sealed inside a machine the size of a small room, strapped into your seat, staring at a checklist, while 2.6 million kilograms of fuel wait beneath you like a restrained disaster. Outside, the rocket looks almost holy. White, silent, clean. A monument of human confidence, standing against the Florida sky. Cameras love this part. The polished hull, the flags. The crew waving like history has already decided to be kind. From the ground, Artemis II looks beautiful. It looks like progress. It looks like humanity returning to the moon. But inside that capsule, beauty means nothing. Because in a few minutes, the only thing separating four human beings from incineration is engineering, mathematics, and the hope that every valve opens exactly when it should. If even one thing goes wrong, the sky does not care. This is not a mission to land. That almost makes it worse. They are not going there to conquer anything. They are going there to test whether human beings can survive the trip at all. One loop around the moon, around 10 days. Roughly 1.1 million kilometers, through a place that has never once been friendly to life. Farther than any crewed mission has traveled since Apollo 13, the mission the world remembers because space turned a routine flight into a slow-motion negotiation with death. Artemis II carries that memory in its shadow. Every launchpad speech talks about courage. None of them say the more uncomfortable truth. This is still an experiment, and that is what makes it terrifying. The rocket carrying them, NASA's Space Launch System, has flown before, but never like this. Orion has been to deep space, but empty. This is the first time the full system will be asked the question that matters most. What happens when there are actual bodies inside? Breathing bodies, fragile bodies, bodies that need oxygen, temperature control, water, pressure, waste systems, clean air, stable communication, and a shield strong enough to survive returning to Earth faster than a rifle bullet. Every system has to work together. Not in theory, not in simulation, not on paper, in reality, with people. But here's the problem. Spaceflight does not usually fail in dramatic movie explosions. It fails in whispers. A leak too small to see. A pressure reading that drifts. A seal that behaves differently in vacuum than it did on Earth. Artemis II already had warnings. Hydrogen leaks. Helium flow issues. The rocket had to be rolled back into the vehicle assembly building in February 2026, so engineers could open it up, inspect it, fix it, and convince themselves the problem was behind them. By March 31st, NASA gave the mission a unanimous go. No major technical issue remained open. The crew arrived at Kennedy. The vehicle stood at Launch Complex 39B. The countdown moved closer. And this is where things change. Because once that countdown reaches zero, caution becomes momentum. At 18:24 Eastern Daylight Time on April 1st, 2026, if weather and hardware hold, the engines ignite, the boosters light, and the vehicle stops being a machine on a pad and becomes a controlled emergency. The whole stack will claw upward through air thick with vibration and flame, dragging human hearts with it. From that instant on, there is no safe way back. Only the mission, only the trajectory, only the thin idea that this path through the dark has been calculated well enough for humans to borrow it and survive. The first violence comes all at once. 4 RS-25 engines ignite beneath the core stage, and for a fraction of a second, the rocket seems to hesitate, as if even this machine understands what it is about to do. Then, the solid boosters erupt, and Artemis II tears itself off the pad with the kind of force the human body was never designed to trust. Inside Orion, the crew does not experience triumph first. They experience pressure, bones pressed into seats, vision trembling from vibration. The capsule shakes like it is being ripped apart, molecule by molecule, while outside, a column of flame longer than a city block hammers the air below. From the ground, it is magnificent. From inside, it is controlled chaos. For the first 2 minutes, the rocket is passing through the thickest part of Earth's atmosphere. the place where speed and pressure combine into one of the most dangerous moments of ascent. Max Q, maximum dynamic pressure. It sounds technical, almost harmless. But what it really means is this. The vehicle is being punched by the atmosphere at the exact moment it is trying hardest to outrun gravity. If structure, guidance, or propulsion drift too far out of alignment here, the mission does not end quietly. It ends in fragments. The crew never even sees the danger. They only feel the machine shudder and trust that someone, somewhere, predicted every possible way it could fail. But it gets worse, because surviving launch is only permission to face the next threat. Once the boosters separate and fall away, once the stages do what they were built to do, Orion is placed into a temporary orbit around Earth. This should feel like relief. The violence is over. The blue curve of the planet fills the windows. The capsule is weightless now, almost peaceful, drifting above the world like a miracle. This is the beauty people dream about. Continents sliding under thin clouds, sunlight gliding across oceans, the black of space, so perfect it looks unreal. But something is wrong with that beauty, because orbit is not safety. Orbit is delay. Artemis II is not staying near Earth, where rescue is at least imaginable. It is preparing for the burn that matters most. Translunar injection. TLI, 4 letters that sound procedural, clinical, routine. In reality, it is the moment the mission stops belonging to Earth. The interim cryogenic propulsion stage must fire with astonishing precision, pushing Orion out of orbit and onto a path toward the moon. Too little energy, and the spacecraft may never reach the right trajectory. Too much, and small errors stretch into catastrophic distances. In deep space, being off by a little can mean missing home by thousands of kilometers. And this is where fear becomes stranger, because the crew is not just leaving Earth. They are leaving behind the protection Earth has quietly given them their entire lives. The magnetosphere, the cocoon of civilization, the constant presence of air, rescue, and immediate return. Once Orion commits to that burn, it enters a region where there is no quick turnaround, no nearby station, no hand reaching up from the planet below. There is only the hybrid, free return trajectory, a path designed so gravity itself may bring them home if everything starts falling apart. May, not will, may. That single word is enough to make the whole mission feel colder, because a free return trajectory is not a promise of safety. It is an admission that something could go very wrong so far from Earth that the only rescue plan is celestial mechanics. If the spacecraft suffers a major failure after TLWARS, there will be no dramatic docking, no backup crew racing upward, no second chance launched from a pad. There will only be 4 people inside a minivan-sized capsule, watching Earth shrink into a star-bright object behind them, while the moon grows ahead like a destination and a warning. After translunar injection, the silence changes. Near Earth, silence still feels temporary, familiar, like the pause between instructions. But once Orion begins the outbound journey, that silence becomes geographic. It becomes distance. The spacecraft is now moving through cislunar space, a region so empty that even the smallest mechanical sound inside the cabin starts to feel intimate and threatening. A fan, a relay click, a warning tone, the hum of life support. Every noise matters, because every noise means something is still working. And in deep space, still working is the closest thing humans get to comfort. At first, the mission still looks graceful. Earth recedes into a blue-white sphere, suspended in darkness so absolute it almost looks artificial. The moon waits ahead, pale and dead and impossibly calm. Inside Orion, the crew tests systems, monitors consumables, checks guidance, communications, environmental control, oxygen levels, carbon dioxide removal, temperature, humidity, power, waste systems. The capsule is about the size of a minivan, which sounds manageable until 4 people are trapped inside it for days, with nowhere private to stand, nowhere to walk, nowhere to escape the presence of the others or themselves. In low Earth orbit, astronauts can at least feel close to home. Here, every hour makes home more theoretical. But here's the problem. Deep space is not just empty. It is hostile in ways the human mind cannot easily picture. Low Earth orbit still lives under the protection of Earth's magnetic field. Artemis II will go beyond that protection. Out there, radiation is no longer a background fact. It is an active threat, invisible, silent. It does not arrive with impact or sound. It passes through skin, through metal, through tissue, through the body's most delicate systems. A solar particle event, if strong enough and badly timed, can turn space from dangerous to lethal without changing how the cabin looks at all. Orion carries shielding, sensors, procedures. NASA has modeled the risk. But no shield turns deep space into a safe place. It only turns it into a survivable one, hopefully. But it gets worse, because radiation is only one enemy. The real horror of deep space is that survival depends on a chain of small systems that are each allowed to fail exactly 0 times. The air scrubbers cannot stop. The thermal control system cannot drift. Power cannot vanish. Guidance cannot become uncertain. Communication cannot collapse at the wrong moment. On Earth, a malfunction is an inconvenience until proven otherwise. In deep space, a malfunction is a countdown. If carbon dioxide starts rising, it does not matter how beautiful the moon looks through the window. If heat builds in the cabin or cold creeps through the structure, it does not matter how historic the mission is. History cannot keep anyone alive. And this is where things change again, because as Orion closes in on the moon, the crew is not approaching a destination that welcomes them. They are approaching a body with just enough gravity to alter their fate, and just enough distance from Earth to make every mistake feel permanent. Soon, they will pass behind the far side of the moon, into the one place on the mission where the spacecraft, the crew, and all of human history will be separated by rock, distance, and silence. And for a few long minutes, nobody on Earth will be able to hear them at all. The far side of the moon is where the mission becomes supernatural. Orion approaches a world humans know by image, by myth, by reflected light, but not by intimacy. The near side is familiar only because Earth has stared at it for all of human history. The far side is different, scarred, older-looking, violent in silence. Craters inside craters. Impact basins so large they feel less like wounds and more like memories of some ancient catastrophe. As the spacecraft curves around that dead horizon, Earth disappears, not fades. Disappears. One moment it is there in the window like a promise. The next it is gone. And this is where things change. Because the loss of Earth is not just visual. It is operational. The moon itself blocks the signal. For roughly 30 to 45 minutes, sometimes longer if something unexpected interferes, Mission Control cannot speak to the crew. The crew cannot speak to Mission Control. No calm voices from Houston, no instant troubleshooting, no reassuring updates. Just 4 people in a capsule, moving behind a planetary body, hearing only the machinery around them and their own breathing. If something fails during that blackout, it fails in private. But here's the problem. Space does not need a dramatic failure to become terrifying. It only needs uncertainty. A guidance anomaly during communications loss. A sensor disagreement. A thruster that fires a fraction too long. A software timing issue. A pressure reading that does not make sense. In low orbit, confusion is stressful. Here, confusion feels terminal. Because every second spent not understanding the spacecraft is a second, the spacecraft continues moving anyway. Around the moon, through gravity, deeper into a chain of physics, no human can pause. Orion is using a hybrid, free return trajectory, designed so gravity can swing it back toward Earth even if major systems degrade. It sounds comforting, But what it really means is that the backup plan is not rescue. It is falling correctly. But that's not even the worst part. The moon is not merely scenery in this moment. It is a gravitational machine. Artemis II will pass thousands of miles above the surface, close enough to let lunar gravity bend the entire mission's fate. Too high, too low, too early, too late. Small errors here propagate across hundreds of thousands of miles of return flight. And unlike launch, where danger is loud and obvious, this danger is elegant, invisible, the kind that hides inside perfect-looking numbers until the consequences arrive days later at Earth. Then, contact returns, voices reappear, telemetry comes back. The world exhales. From the ground, it will feel like the most dramatic moment has passed. The spacecraft survived the far side. The crew is heading home. The moon is behind them now. But it gets worse, because deep space has one final test reserved for anyone who dares come back. It will let you survive everything, only to ask whether you can survive the return. The journey back always sounds easier when people describe it from the ground. The moon is behind them. The hardest part is over. The spacecraft is on its way home. But home, in spaceflight, is not a place you simply arrive at. Home is a sequence of survivable disasters. Orion still has to cross the inward stretch of deep space, performing correction burns small enough to seem trivial and important enough to decide whether the capsule meets Earth at exactly the right angle. Not too steep, or the crew burns. Not too shallow, or the spacecraft skips, drifts, and risks turning survival into a second, colder kind of death. In deep space, almost right is just another way to be lost. And this is where the mission becomes cruelly mathematical. For days, the capsule falls toward Earth through black vacuum, carrying exhausted bodies, stale air, recycled systems, and the accumulated stress of being alive inside a machine that has never before carried humans this far in this configuration. Every check matters. Every reading matters. The crew can see Earth growing larger now, bright and beautiful, the kind of image that should feel like rescue. But Earth is not safe yet. Earth is a wall, and Orion is about to hit it at around 25,000 miles per hour. But here's the problem. Re-entry is not landing. Re-entry is controlled destruction. The capsule slams into the atmosphere so fast that air itself becomes a weapon. Compression builds heat beyond ordinary imagination. Around 5,000 degrees Fahrenheit at the heat shield. Hot enough that the plasma wrapping around the spacecraft is not just fire in the cinematic sense. It is physics turning the sky solid. After Artemis I, NASA adjusted the trajectory to reduce thermal stress and moved away from the skip re-entry profile. That should help. It should. But should is one of the most frightening words in exploration, because it means nature still gets a vote. Then comes the blackout, again. Not from the moon this time, but from plasma. The capsule is surrounded by ionized gas that can interrupt communication during the most violent phase of return. For a brief span, the crew is unreachable while the spacecraft takes the full punishment of coming home. If the heat shield fails, there is no correction, no second attempt, no procedure that can negotiate with ablation, shock, and flame. The capsule either survives the furnace or it does not. And if it does, if the parachutes deploy, if the ocean rises to meet them in the Pacific, if recovery teams reach the bobbing capsule and open the hatch, the mission will be called a triumph. And it will be. But beneath that triumph is something older and darker. Artemis II is not terrifying because it might fail. It is terrifying because even when everything works, survival still depends on passing through places no human was ever meant to endure. That is the real truth hidden inside every beautiful launch. Space does not hate humanity. That would make it feel alive. It is worse than that. It is indifferent. And every mission beyond Earth is humanity stepping into that indifference, building a tiny pocket of warmth and breath inside it, and hoping the dark allows us to leave alive.